Hi, hello student. Good afternoon. So let us see the question number 62. Okay, so this is 60. Totally we have done 61 question that has completed. Okay, so now we are going to do the question number 62. Okay, so question number 62 is about an air-filled rectangular waveguide. An air-filled rectangular waveguide with the dimension. An air-filled rectangular waveguide. It is given as air-filled. Given here that air-filled rectangular waveguide air-filled rectangular waveguide with dimension is given with dimension A is equal to broader dimension, this is 75 millimeter, and narrower dimension, so this is about B. Narrow dimension, that is B is equal to 37.5 millimeter. So now he is asking about has the same guide wavelength. So both dimensions have same guided wavelength. Okay, so this is guided wavelength. So this is guide wavelength for this dimension A, and this is lambda G B. So both dimensions have same guided wavelength. It is given here at a frequency of what? At frequency f1 and f2. F1 and f2 both are operated at this frequency. It is given. So then at a frequency this, and both are operated at TE. Okay, so both are operated at TE10 and TE20. Okay, these are the mode at which these are the mode at which this air-filled rectangular waveguide is operating. Okay, and if the frequency of f1, and it is given that if the frequency of f1 is what? F1 is root 13 gigahertz. Then what about the frequency of f2? Okay, so what is the frequency of f2? Okay, what is frequency f2? So now see, this is the data for this air-filled rectangular waveguide. Okay, so now as we know very well, this is air-filled rectangular waveguide, in which for air-filled, as we know very well, relative permittivity is what? 1. Yes, relative permittivity is 1. So with the dimension of this, okay, so which is operated at this mode, TE10 mode. So therefore, first of all, these f1 and f2 are what? Operated frequency. For that, we have to calculate first what? Cutoff frequency. Cutoff frequency for this TE10 mode, which is also a dominant mode. So first of all, what is cutoff frequency for this FC10? Yes, FC10. For FC10, as we know very well, so cutoff frequency is nothing but, so this is what? For cutoff frequency for dominant mode is nothing but, if you see, C by 2A. Yes, C by 2A. So this is cutoff frequency for dominant mode, and cutoff frequency for dominant mode TE20. So this is MN dimension. Okay, MN dimension. So for TE20 mode, the cutoff frequency is FC20 is equal to, if you see, this is M and N value. Okay, as we know simple that cutoff frequency is nothing but C by 2A into square root of M by A whole square plus N by B whole square. Okay, so just put this M and N value in this okay expression, you will get the cutoff frequency. For this TE20, the cutoff frequency is nothing but FC20 is equal to what? When you put this value, M is 2, so you will get 2C by 2A. Yes, so here FC20 is nothing but, it is C by what? C by A. So this is C by A. Okay, so C by A. So these are the cutoff frequency for both mod TE10 mod and TE20 mod. Okay, so now what is asking, that he is asking about what is the operating frequency f2 for which operating frequency f1 is given, that is root 31 gigahertz. Root 31 gigahertz. Okay, so as we know from this case, what guided wavelength for both dimension is same. So we can write here guided wavelength lambda Ga is equal to lambda Gb. Yes, lambda Gb. If we see here, what is guided wavelength is nothing but it is lambda by lambda is equal to c by f. Yes, c, as we know very well, lambda is equal to c by f. Yes, f into square root of epsilon r. This is what relative permittivity, which is given as 1. Yes, because it is air-filled rectangular waveguide. For air-filled rectangular waveguide, permittivity is 1. So we can write here lambda is equal to c by f, which is nothing but c by this is guided wavelength. Okay, so guided wavelength means lambda is equal to, this is guided wavelength. So guided wavelength is nothing but lambda by square root of 1 minus fc 10 divided by fc divided by f1 whole square. Okay, so which is equal to lambda divided by 1 minus fc2 0 divided by f2 whole square. Okay, so this is what this we got from this relation, because it is given both are equal. So this is nothing but what guided wavelength. Guided wavelength is nothing but lambda by square root of 1 minus fc10 by fc1 by f1. fc1 is the cutoff frequency, f1 is what operating frequency at which the waveguide is operating. Cutoff frequency is the minimum frequency. Yes, it is the minimum frequency for which wave will pass. Okay, below this cutoff frequency wave will get attenuated. So there is no transmission through what waveguide. Okay, if the frequency is less than cutoff frequency. So now let us remove this first. Okay, so we have done all this data here. So just jot down this data here. So that is A is equal to 75. That we know. This also we know. Okay. So now that is I am going to remove this. Okay. So let us see. Now this is what lambda. So as we know very well, lambda is nothing but lambda is equal to c by f. Lambda is equal to c by f. Actually, it is lambda is equal to c by f square root of epsilon r, because it is air-filled rectangular waveguide for which permittivity is equal to what? 1. Yes. So now see here. Now see this lambda is nothing but, which implies that c by f into square root of 1 minus square root of 1 minus square root of 1 minus fc1. Yes, this is what operating frequency 1. fc1 that we have calculated how much? c by 2a. So 2a c by 2a into f1 whole square. Okay, whole square is equal to what? Is equal to c by f2, because this is for second dimension f2. Okay, so square root of 1 minus fc2, how much we got? c by a. So a into f2 whole square. Okay, so now see, given that f1 is what? f1 is nothing but f1 is how much? root 13 gigahertz. It is given root 13 gigahertz. Yes. So now see, this cc will get cancelled out. Okay, so just put here value. So this is what? root 13 square root of 1 minus. Let us calculate this also. c by 2a, how much is c by 2a? c by 2a is nothing but 3 into 10 to the power 8 divided by 3 into 10 to the power 8 divided by 2a. A is how much? 75 millimeter 10 to the power minus 3. Yes, it will go up. this is 10 to the power 11, 3 by 2. So 10 to the power 11. Okay, so if you will do this, it will come 1.5 divided by 75 into 10 to the power 11. Yes, so this is nothing but 15 by 75 into 10 to the power 10. So this is 1 by 5. Yes, so this is 1 by 5, 10 to the power 10. So which is nothing but 2 gigahertz. 2 gigahertz. Yes, 2 gigahertz. We got what? We got F1. F1 is equal to 2 gigahertz. 2 gigahertz. Not F1. This is FC1. Yes, FC10. That we got 2 gigahertz. 2 gigahertz. Similarly, if you see here, what FC2? FC2 is nothing but C by A. C by A, 3 into 10 to the power 8 divided by, how much is A? For A is nothing but 75 millimeter. So this is 10 to the power minus 3, 11. So this is what? 3. So 3 into 10 to the power 11 divided by, how much? This is 75. And it become how much? 3, 120. This is 1 by 25 into 10 to the power 11. So this is 100. This is nothing but 4 gigahertz. How much? 4 gigahertz. Now we got FC20. FC20 as what? FC20 is equal to how much? 4 gigahertz. 4 gigahertz. And FC1 is 2 gigahertz. Yes, FC1 2 gigahertz. Now these two frequency, now we are going to put in this expression. Okay, so now we will get. So just see here. This is what? This is 1 by see 1 by F1. F1 is nothing but root 13 into 1 minus 1 by this FC1. How much we got? C by 2A. How much? 2 gigahertz. 2 gigahertz. 2 by F1. F1 is given as root 13 whole square. Yes, whole square equal to how much? 1 by divided by. This is what F2. F2 is not given, so this is just left it as it is. Okay, so this is F2 square root of 1 minus. This is C by A. How much we got? FC20, that is 4 gigahertz divided by F2. F2, this is F2 whole square. So now just take this term this side and square on both sides. What we will get? F2 square into 1 minus 4 by F2. 4 by F2 whole square. Yes, 4 by F2 whole square is equal to, if you see here, 13 into 1 minus how much? 2. This is nothing but 4 divided by 30. Yes, when you will square on both sides. Okay, so now this is 13 into 1 minus 4 by 30. So see here, F2 square 1 minus 16 divided by F2 square. F2 square is equal to how much? 13 minus 4, 9 by 13. This is nothing but 9. Yes, this is nothing but 9. Now see, F2, F1. Okay. Okay. So this is what? F2 square. F2 square into F2 square minus 16 is equal to 9 F2 square. Yes, F2 square. Now, if you see here, F2 square will get cancelled. Okay, so now this is what? F2 square. F2 square minus 16 is equal to 9. So which implies F2 square. F2 square is equal to 25. Then F2 is equal to how much? 5. What? 5. So this operating frequency is in what? Gigahertz. So therefore we got what? F2 as 5 gigahertz. Yes, nothing we have to do here. What? Just simply put the value of this cutoff frequency here. First, we have to calculate cutoff frequency for both mode, that is TE10 mode and TE20 mode. Okay, so just care about what value of m, because in case of what TE20 mode, so there we have to put the value of m. Okay, so the difference is only this. Okay, and just remember the expression for what guided wavelength. Expression for guided wavelength is nothing but lambda g. Lambda g is equal to lambda divided by 1 minus fc, cutoff frequency, divided by operated frequency f naught 0. Okay, so or you can write this as fg is equal to what? Fg is equal to lambda divided by 1 minus 1 minus lambda naught by lambda c. Okay, if you want to write in term of wavelength, then it is just opposite of that frequency. Okay, opposite of that frequency. Here operated wavelength, that will come outside. Okay, so here cutoff frequency is at outside. Okay, so now see, this is about what air filled rectangular waveguide whose both dimension is given, and given that the guided wavelength for both the dimension is same. Okay, is similar, and it is given that if the operated frequency for f1, if the operated frequency f1 is root 13 gigahertz, then what about the frequency f2? What about the frequency f2? Just we have simply put this all the value into this expression of guided wavelength. Okay, and here in the question that is given that the guided wavelength for both the dimension is same. Okay, and air filled waveguide, for that, as we know very well, permittivity is what? 1. Permittivity for air is what? 1. Okay, so that is what answer. F2 is equal to 5 gigahertz. F2 is equal to 5 gigahertz. So then we can say that option number B is what? Correct. Okay, so that's all about this question. Okay, thank you very much. Okay.